Have you ever thought how long does it take for a space shuttle to reach the International Space Station? And also, after reaching the outer space, how does it exactly get to the space station for docking? Well, the answer is quite interesting. One might think that leaving the Earth is the hardest part because of the atmospheric friction and the gravity pulling the rocket downward. But in reality, if we talk in relative terms, then it is easier to reach the outer space than catching up with the International Space Station orbiting around the Earth. Because what we seem to forget is that the International Space Station orbits the Earth at a speed of 27,576 km per hour. And on Earth, even the fastest aircraft can only move at a speed of 2,500 km per hour. So catching an object moving as fast as the International Space Station is an incredible feat and a tough job to complete. So now the question arises, then how does the spacecraft catches up with the International Space Station, and also how can we achieve it using the least amount of fuel? Now to catch up with the International Space Station or ISS, the spacecraft and the ISS have to be at the same height and at the same velocity, and this is quite hard to achieve. First of all, the spacecraft is launched from the Earth and using thrusters and propellant it achieves a speed of 28,080 km per hour, which is the minimum speed required for a lower Earth orbit. Once the spacecraft reaches the space, the astronaut fires the thruster parallel to the Earth's surface so that the spacecraft can start orbiting the Earth properly. But at this point, the orbit of a spacecraft is lower than that of the ISS. To take the spacecraft to a higher orbit, the astronaut performs what is called the Hohmann Transfer. In orbital mechanics, the Hohmann transfer orbit is an elliptical orbit used to transfer between two circular orbits of different radii around the central body in the same plane. So this is the theoretical aspect. Now let's see how it is actually used in this case. Now first of all, one thing you might have noticed is that the spacecraft has higher velocity than the International Space Station. And this is in agreement with the fact that in orbital mechanics, objects in higher orbits have lower velocity than the objects in lower orbit. And this small detail is quite important if we want the ISS to catch up with the spacecraft, as you'll find out later. Now for the Hohmann transfer, when the spacecraft reaches at an appropriate position, the astronaut fires the thrusters for the first time, which changes the circular orbit into an elliptical orbit. This elliptical orbit is such that it coincides with the circular orbit of the ISS. Now when the spacecraft reaches at the other extreme of the elliptical orbit, astronaut fires the thrusters the second time so that the elliptical orbit changes into the circular orbit again. And this is how the Hohmann transfer is executed. So finally, after catching up with the ISS, the spacecraft is carefully docked with it so that the astronaut can access the International Space Station or any other cargo could be transferred. Now a question which might come to your mind is, if the higher orbit is at a lower velocity, then why are we firing thrusters to reach there? And the answer is quite simple. You see, the higher orbit is at a lower velocity, but it is also at a higher gravitational potential energy. So by firing thrusters, astronaut increases the kinetic energy of the spacecraft, which is gradually converted into potential energy as it starts revolving in the circular orbit of ISS. Another question you might ask is, why can't we simply fire the thrusters away from the Earth to raise the altitude of the spacecraft? And the answer is, we don't do that because it is not very effective and might lead to unexpected results. You see, a space shuttle orbiting around Earth already has velocity along the tangent to the orbit, and by firing thrusters away from Earth, we give it another velocity perpendicular to the orbit's direction. And both of these velocity vectors together gives a resultant vector which is in this direction. Now this resultant vector does increases the altitude a little, but it also changes the orbit's trajectory. And this new orbital trajectory could lead to the space shuttle crashing with the Earth. And because of these reasons, this method is not used. So finally, in conclusion, It takes only 10 minutes for a spacecraft to reach from the Earth to the space, but it may take hours or even days for the spacecraft to catch up with the International Space Station.